Hey everyone, Brad here with REV Robotics. I'm joined today by Christine from our education team to walk through the programming for the 2026 REV Duo FGC Starter Bot for the first global challenge, Igniting Innovation. This year's challenge brings teams from around the world to Incheon, Republic of Korea, where students will use engineering, creativity, and bold new ideas to explore wildfire prevention, response, and recovery. In this video, we'll take a look at the StarterBot code, how it helps turn your build into a moving, working robot. You can find the full code and blocks at docs.revrobotics.com.
Programming is where your robot really starts to come alive. It can also be one of the first big questions for teams of where do we get started? Before jumping into the code, make sure your devices are updated with the REV hardware client, your batteries are all charged, and your robot is ready to safely test.
Start with your robot configuration. This helps the control hub understand what is connected to each port, so your code knows how to communicate with the motors, servos, sensors, and more on your robot. You can load our configuration as a starting point, then use the documentation to follow the wiring diagrams, gamepad layouts, and downloads for the full blocks code. From here, Christina's going to walk us through the key features of the code and show how this starter bot can help teams spark their own ideas for the first global challenge.
All right, let's dive into our coding guide. Right now I'm on the landing page for programming the starter bot, and all the way at the top I can see the configuration breakdown of where everything's plugged into, because we are using both the expansion hub and the control hub, and it tells me which port number I'm using and what are the names for each device. You can decide to change these. Just make sure that if you make that change, especially to the name of the device, that it's also changed in the code and the configuration. That way, when I go to run a code, I don't end up seeing an error on my driver hub because of a mismatch. Right below, I have my configuration file available for download. And if you've never made a configuration file before, you can use this as a starting place and just add it to your control hub. Or you can go through our tutorial on how to make a configuration file from scratch, so that way you can pick what specific ports and names you would like to use. Below, I have our wiring diagram showing where everything's laid out between the control hub and the expansion hub, and how those two are connected together as well. If you decide to change this is another thing. We'll make sure your configuration file is also up to date so that everything matches. But for us, when we went through experimenting with this, we tested some different layouts to see what worked best where, and this is how we kind of determined worked best to make sure that the wire management stayed clean, nothing was getting caught somewhere or in the way. So that's how this got determined of how to lay different things out. Below, I have my Gamepad Setup. On the starter bot, the gamepad, we can see that the left joystick is controlling my drive. It is just using a standard arcade drive. If I wanted to switch this to a right joystick, I can do so, and we can go over that in just a moment. But as you get practicing too, you might decide, I want to try a split arcade drive, and you can easily adjust that within code. I also have my triangle and my square controlling my climb controls. I have my launcher set to cross so that it will activate the flywheel and automatically feed in the game pieces. And then lastly, my left and right bumper will control feeding game pieces in and out from on the floor of the field. Then at the very bottom of this page, I have the download for the blocks program itself, which I can go ahead and upload to my control hub, go in and make sure to save the op mode, and then I should be good to go ahead and run it for the first time. We're going to look step by step of what the different parts of the code do, starting with initialization. And this is the part of the code that when I'm looking at the driver hub and I hit initialization, but not play yet, things that will run. So in this case, I need to set up a couple of things, starting with my motor settings. Because I have my drivetrain motors mirrored of each other, I have one set to run in reverse. That will keep me from just spinning in a circle. Then we have turning on the encoders for both flywheel motors, because we're using velocity control on this robot as part of the launcher system. And so I need to go ahead and make sure that's on so that I can count ticks properly. Lastly, I have a variable set up as part of my initialization. A variable is going to hold a piece of information for us. And in this case, it's holding my target velocity number. So how many ticks am I trying to rotate per second? If I decide to change that number to make it bigger or smaller, I can change it here in the initialization without having to hunt down everywhere I used it within my code. We can look here at our arcade drive. So I can see it says left stick and X and left stick Y. If I wanted to switch to the right joystick, I can just switch it using that drop-down menu to the right stick X and right stick Y and make that adjustment. But otherwise, it's using a pretty standard arcade drive. You might notice that the Y-axis in particular is set to a negative, or it's set to use negative numbers. That is just because with the control hub, it is going to automatically be inversed. If you prefer an inverse control with that Y-axis, you can remove that negative. Down below, I have my climb control, and I can move forward and back with that motor to help balance myself out as I'm climbing. So triangle is going to go one way and square is going to go the opposite way. And then if neither button is pressed, it will turn that motor back off. So when I'm just generally driving around picking up game pieces, it shouldn't be spinning at all. Switching over to my intake, we can see it's a similar control. And just to talk a little bit more about an if-else statement, as mentioned, I'm just checking which button is being pressed right now, or is any button being pressed. So similar to our climber, this is checking if my left bumper is pressed, I'm going to intake game pieces. If my right bumper is pressed, I'm going to outtake game pieces in case I have too many or it's jammed, just to be able to have extra control. And then if no button is pressed, it will also stay off. All right, so let's take a look at our last section of code, which is our biggest section of code for our launcher. And this is controlling the flywheel and the core hex running the feeder so that we have game pieces automatically feeding into the flywheel and launching up into our goal. As part of this, when I press cross, the two flywheel motors are going to try to spin up to that target velocity. And then that core hex is actually going to wait until it's within a certain range to actually start feeding in the game pieces. And that range right now, I have it set to be within 100 ticks. As you test, you might decide to make that bigger or smaller. But that is where I have it currently set so that we can make sure we're actually up to that target velocity before, so we don't fire too soon or too late. We also have manual control for that core hex motor. So if I need to just rustle around the game pieces within the robot or clear up a jam, I can do so and have a little bit more refined control. And of course, similar to what we've talked about previously, if no button is being pressed from this if-else statement, the motors will turn themselves off. And then all the way at the bottom, we have about our telemetry. And so telemetry is going to give you a readout to the driver hub on some information. In this case, I'm looking at what is the current velocity of my two flywheel motors. And this will help me with fine tuning to decide if I want to try to go a little bit higher in that velocity, a little bit lower, if I need to adjust how many ticks I'm waiting before I start having that core hex spin. It will just help you with troubleshooting and kind of refining what your robot is doing as you get going. And that is everything for our code tutorial. Hopefully this is a good starting point for getting going and testing out your robot. And then you can build from here with even more blocks and more capabilities with your robot.
Thanks, Christine, for helping walk us through the StarterBot code. To learn more, check out docs.revrobotics.com for the full CAD, build guides, code overviews, wiring diagrams, and more. For more about the first global challenge in this year's game, Igniting Innovation, visit first.global/FGC. Feel free to leave a comment on this video or contact our support team at support@revrobotics.com. Good luck to all the First Global teams around the world, and we can't wait to see what innovation you ignite.